Fusion is the reaction that powers the sun. To run it on Earth, you have to hold a gas hotter than the sun's core inside a magnetic field, without ever letting it touch a wall. Our breeder machine, Hyperion, is how we do it. Hyperion is a spherical tokamak. A conventional tokamak looks like a donut. A spherical tokamak looks more like a cored apple, squeezed in tight around a slender central column. That shape is not a style choice. It is a physics advantage. By pushing the plasma close to the axis, we run at a low aspect ratio, about 2.5, with a major radius of just 1.2 meters. Compact geometry lets the plasma hold more pressure for a given magnetic field, so the machine is smaller and works the field harder. Inside, the fuel is deuterium and tritium, two heavy forms of hydrogen. When they fuse, they release a helium nucleus and a neutron carrying 14.1 million electron volts. That neutron is not waste. For us, it is the product. To make that reaction happen at all, three things have to be true at once. The fuel must be hot, it must be dense enough, and it must stay confined long enough. Multiply those three together and you get the triple product, the single number that decides whether a plasma fuses. Push the triple product past a threshold, called the Lawson criterion, and fusion power starts to dominate. The reaction rate peaks in a window around 10 to 20,000 electron volts, a very specific, very hot operating point that the machine has to reach and then hold. When we simulate Hyperion at that operating point, it produces a fusion gain, Q, of 3.424. That is the ratio of fusion power out to heating power in, solved, in open simulation. To be clear, this is a conceptual design, validated in open simulation, not yet an operating machine. At that gain, the plasma generates 88.7 megawatts of fusion power. That is a real engineering scale burn, enough to drive everything the machine is built to do. Here's the part that makes Hyperion different. A power plant has to make more electricity than it consumes. Net power. Hyperion does not. It only needs fusion gain. That is because Hyperion is a foundry, not a power plant. It does not sell electricity. It uses its neutrons to breed and make materials. Tritium, helium-3, and a stream of 14 million electron-volt neutrons for testing and industry. Because the product is material, not electricity, the economics do not wait on net electric gain. We need the reaction to run and to breed. That is a milestone the field can reach far sooner than a full power plant. This is the wedge we work in. Scientific gain and engineering gain are two different bars. Selling materials clears the scientific bar. It does not require the much higher engineering bar that stands between the field and grid electricity. Everything here is published. The full breeder design and its simulations are open. You can find them under our Zenodo record and check the numbers yourself. We label every claim as shown, gated, or assumed. So that is Hyperion, a compact spherical tokamak, a solved gain of 3.424, 88.7 megawatts of fusion power. and a foundry that turns neutrons into the materials the rest of the industry still needs. Gain first, then everything else follows.